Good morning, students. Today we will start chapter number 8, application of integrals. We have learned formally to calculate areas of various geometrical figures, including triangles, rectangle, trapezium, and circles in the previous classes. Such formulae are fundamentals in the application of mathematics to many real-life problems. The formulae of elementary geometry allows us to calculate area of many simple figures. However, they are inadequate for calculating the areas enclosed by curves. For that, we shall need some concept of integral calculus. It means we will use concept of integration and find the area enclosed by figures or area under the given curves. This is the application of chapter 7. In the previous chapter, we have studied to find the area bounded by the curve y is equal to fx, the coordinates x is equal to a, x is equal to b, and x-axis, while calculating definite integral as the limit of a sum. This topic this year is related from the syllabus, from the integration, chapter 7. Here in this chapter, we shall study a specific application of integrals to find the area under simple curves, area between lines and arcs of circles, parabolas, and ellipse. We shall also deal with the finding the area bounded by the above said curves. Here we will use the concept of integration and find how to find out the area of the given figure. That figure is under the curve, between two lines, between two circles, the curve of the two circles, parabola and line, ellipse and line, and few other concepts of enclosed region we will study in this chapter. Here, first of all, we will study what type of concept we will use in this. That is first, area under simple curves. Here you can see, this is a figure 8.1, it is given here. Suppose curve y is equal to fx function, curve is SR curve. And we have to integrate this area under this curve from the point x is equal to a to x is equal to b. For this, we can divide this area under this curve into small rectangles, like this. Here one of the rectangle is given to you. Let this height is y, and this small part, it is curve, but when it is a smallest one, then it is looks like a line. So this is a small dx. It means dx, and this area of rectangle is length into breadth. And what is the area? Y into dx. Now this is the area of the rectangle which is formed here. One rectangle. If number of rectangles are formed here from A to B, then we have to use the concept of integration by using the one rectangle area and finding the area which is under the whole curve. That is a formula which we will study. Yes, area under the curve can be calculated. This can be calculated. Area is equal to integration from limit a to b and the area of one rectangle which we have calculated, that is y into dx. Integrate this area from point A to B, you will get the area under that whole curve from A to B. If the curve is not like, which we have studied like this, which is not like this, which is like this one. Suppose curve is like this one, and the function is y is equal to gy. Here you can observe, now as we have taken x is equal to a and x is equal to b in the previous graph, here we will take what? This is y is equal to c and y is equal to d, because we are taking this one and this one. Now if we form a rectangle, as one rectangle is shown in the figure, let this is the x and this is the dy, because it is on a y-axis, so it is a dy. Now area of this rectangle will be x into dy, and we have to integrate, we have to calculate whole area, so we will integrate from c to d to the function g into dy. Now g into dy can be calculated from limit c to d, will give you whole area which is shaded in the figure 8.2. So here are two ways. First, whether this strip is um, parallel to x-axis or parallel to y-axis. It depends on the given graph or given curve. One more thing we have to observe here. If the graph is like this, as it is shown in the figure 8.3, as you see here, the whole graph is under the x-axis. Under the x-axis. Whenever the graph is under the x-axis, it means you will get the negative value of the area. But as you know that area cannot be negative, so what? You have to take the mod of the whole area. Here it is written, take its absolute value. If you integrate from a to b, one of the strip this y into dx, here it is fx into dx, then you have to take the absolute of this. It means mod of the value which is calculated by using integration from a to b to the function fx dx. Suppose it is minus 42. It means you have to take only 42. It means you have to take the absolute value of the solution. Suppose the graph is not like this. One other type of graph you will get, that is, suppose like this, half of the graph is positive and left of the graph is negative. It means what? You have to take, suppose this is the A1 area and this is the A2 area. You calculated A1 area, it is negative, so you have to take absolute of this. Then area of A2, then you will get the area A. Whole area you can calculate by taking A1 plus A2, and you have to take the absolute value of A1. It should be shown in the, let's see. Yes, here it is written. A will be equal to, area will be equal to mod of A1 plus A2, that is the area of the given figure. It means whenever you are getting negative value in, numerically, you have to take the absolute value of that. It means this becomes the area of figure. Now here is example first. Before we go for the example, I just want to tell you, you have studied chapter 11 in class 11th. Class 11th, and you have studied chapter 11, that is a conic section. In that chapter, we have studied different curves. First is circle, parabola, ellipse, hyperbola, these curves we have studied in chapter 11. Here in this chapter, we will use especially these three curves: equation of circle, equation of parabola, and equation of ellipse. All these curves equation you must know, because these are used in this chapter, chapter number 8. Here is example number first. Find the area enclosed by the circle x square plus y square is equal to a square. Now you must know this is the equation of circle. You have to plot a rough graph and you have to calculate the area enclosed by this circle. Now from this equation you can see here equation of circle is like this. When the center is HK and radius is R. If center is 0, 0, you are getting equation like this. It means here in this equation, center will be 0, 0, but radius will be equal to A. You can compare this A square by a small r square. You are getting R is equal to small a. The whole area enclosed by this circle you have to calculate. You can see here the circle is symmetrical about x-axis as well as y-axis. It means these four parts are of having same area. If you calculate area of one portion from A to B and multiplied by 4, you are getting the whole area of the circle. So for what? For you have to calculate only one area, multiply that area by 4, you are getting the area of a circle. Now for first part, this one part, you have to take the strip, this one rectangular strip, y into dx, integration from what? From here to this part. Here you can use, here you are integrating the function with respect to x. It means limit of x will be there. From the limit will be what? From a to 0 to a. The limit is from 0 to a. That is the part, and y dx integration is from 0 to a, and the value of y you can calculate x square plus y square is equal to a square. The value of y can be calculated from here. Plus minus sign is there, but it is the first quadrant, you have to take positive. So that is under the root a square minus x square. Now here you have to apply the formula from the integration. That is x upon 2 under the root a square minus x square plus a square by 2 sine inverse x upon a. Integration is from 0 to a. Now apply the upper limit minus lower limit. Upper minus lower. Lower is 0. That makes the statement 0, and put a in the upper limit. Here first part is 0, but second part is a square by 2 sine inverse 1. And when sine is 1 at pi by 2. So it comes out pi 4 into a square by 2 into pi by 2. That is pi into a square. This is the answer. Area enclosed by the circle from limit 0 to a. Now, this same question can be done by taking the strip parallel to x-axis, x dy. Here you have to take the value of x from x square plus y square is equal to a square. You have to calculate x, that is a square minus y square. Apply the formula, put the limit. Same question can be done by taking the strip parallel to x-axis. So we have done question by taking strip parallel to x-axis as well as parallel to y-axis. Now next example. Find the area enclosed by the ellipse x square upon a square plus y square upon b square is equal to 1. Now equation of ellipse is given to you. Area enclosed by this ellipse. Now as you know, this is the ellipse. As you know, this is a graph which we have studied in class 11th. Ellipse x square upon a square plus y square upon b square is equal to 1. Now for this, here we have taken the strip parallel to y axis, y into dx. That area of rectangle is y into dx. So value of y you have to calculate from where? From the given curve. Here it is calculated, y is equal to b upon a under root a square minus x square with plus minus sign. Here it is in first quadrant, you are taking positive. Okay, it is written in the first quadrant, y is taken as positive. So the required area will be equal to 4 times, because you want the area of whole ellipse. Ellipse is symmetrical about x-axis as well as y-axis. That's why if you calculate the area of one part and multiply that part by 4, we are getting whole area of the ellipse. Same is here. 4 times of y dx. Y is this one. The value of y is b upon a under root a square minus x square with respect to x. Now apply the formula root a square minus x square and apply the limit upper minus lower limit. First put a and then 0. We are getting answer pi ab. Pi into ab. Same question can be done by taking strip parallel to x-axis. Now you can do it. The area of the region bounded by a curve and line. In previous examples, we have studied only curves. Now, if line and curve both are given to you, then how to calculate the area enclosed by curve and line? Find the area of region bounded by the curve y is equal to x square and the line y is equal to 4. As I have told you, you must have a knowledge of chapter 11 conic section. Now, if you don't know what type of curve this is given to you, then you can't plot the graph. Here y is equal to x square means, y is equal to x square means, as you have studied this equation, that is a parabolic form where the graph which is symmetrical about y-axis, positive y-axis. Positive y-axis. So here you can plot the graph x square is equal to y, or you can say this is a upward parabola. This is a upward parabola, and one line given y is equal to 4. Here is a 4 on the y-axis, and y is equal to 4 means a line which is parallel to x-axis. This is a line, y is equal to 4. This is a line. The area enclosed by these line and parabola. It means you have to calculate one part of this boundary region and multiply that part by 2. You will get the whole area, this one. So here we have taken the strip that is parallel to x-axis, x into dy. X into dy means you have to put the value of x here in the form of y. From where you have to take the value? From the curve. The value of x will be equal to under the root y. Now put the value x is equal to root 5. That is root y dy and 2 times. Now you can integrate it and put the limit from 0 to 4. You will get the answer. Area enclosed by the line and parabola. This is the answer. Root y integration is there. Y to the power 3 by 2 divided by 3 by 2. This comes out here 2 by 3. And integrate from 0 to 4. Put the value 4 here and 0. 0 makes the statement 0. And solve the statement. You will get answer 32 by 3. Alternate way is given when you take the strip parallel to y-axis. Now next one is, that is example number 4. Line and a circle. Find the area of the region in the first quadrant enclosed by x-axis, line y is equal to x, and circle. Now you have to plot the graph. Circle with center 0, 0. and here r square is 32, and then r will be equal to root 32, or you can say it is equal to 16 into 2, that is 4 into 2. It means radius is equal to 4 root 2. This is the radius of the circle. So point A will be 4 root 2 into 0. So this is 4 root 2. Now the line y is equal to x is a line. If x is 1, y is 1, x is 2, y is 2, x is 0, y is 0. It means a line which is passes through the quadrant, second and third quadrant, both positive and both negative. So here is a line y is equal to x, where this line x is y is equal to x and circle intersect to each other, you have to find out. It means x square plus y square is equal to 32. This is the equation of circle. Second is y is equal to x. Now solve these two equations, you will get the intersection point of circle and line. Now this equation becomes what? X square plus x square is equal to 32. 2x square is equal to 32, and x square is equal to 16, and x is equal to plus minus 4. Now you can see here x is equal to 4, y is equal to 4. X and y both will be same. If x is minus 4, then y will be minus 4. This is a line, and intersection points are 4, 4 and minus 4, minus 4. Now we have to solve the question. We have to take the region enclosed by x-axis, line and circle. This is x-axis, this is a line, and this is a circle. It means what? This one area we have to calculate. For this, now what you have to take now? You have to take strip like this which is parallel to y-axis. It means y dx we have to take. And integration from 0 to 4 root 2 y dx. What is y? You can put the value of y from the circle. Now, where the intersection point come, here you must know the graph. Just here 0 to 4. First we have to 0 to 4 root 2 you have to require, but intersection from intersection point you have to plot the perpendicular. Two parts are there. First part which is under the line, second part which is under the circle. 0 to 4 root 2 you can move by taking 0 to 4 under the line and 4 to root 4 2, that is from under the circle. Two parts are here. First part 0 to 4 area under the line. Line means y is equal to x. Integrate the x square by 2 and put the limit 0 to 4, we are getting 8. This is the first part. Now for the second part, this one part, this perpendicular is drawn. Area under the circle, this is a circle. And limit is from 4 to 4 root 2. Just see. Yes, 4 to 4 root 2. Integrate the second part. And the value of y from the circle is under the root 32 minus x square. You have to apply a square minus x square formula. Put the formula and apply the limit. And after putting the values here, you must know about the value where sign is 1. Here you have to put sin pi by 2. This is 1. Where it is 1? That is pi by 2 is solved. We are getting 8 pi. Okay. And here you have to put 45. Simplify it. This becomes 0. This is and pi by 2. This comes out 8 pi. Yes, it is 8 pi. Here we will solve it. We are getting 4 by 2 under the root 16 means 4. 4 fours are 16 divided by 2, that is 8. It is 8. Now this is 16 and this is pi by 4. 1 by root 2, 45. 45 means pi by 4. This is 4 pi. So it comes out 4 pi minus 8. And when you are adding first part and second part answer, you are getting 4 pi is answer. Cos 8 plus 4 pi minus 8 cancel and you are getting 4 pi. This is example number 4. Now example number 5. Find the area bounded by the ellipse x square upon a square plus y square upon b square is equal to 1 and the ordinate x is equal to 0 and x is equal to AE. What is the meaning of AE? In the ellipse, C is equal to A into E. We know that the focus at coordinate C comma 0. Here we will write AE comma 0. Here the coordinate AE comma 0. When you want to find out the whole area, this one, here one strip we have to plot it. That is rectangular strip parallel to y-axis. It means this is y into dx. This is dx and this height is y. Put the value of y. From where you have to calculate y? From the ellipse equation you will get y, that is under root of a square minus x square, and integrate from 0. This is the point where coordinates are 0, 0. From 0 to AE we have to calculate the limit on the function under the root a square minus x square. Apply the formula. After applying formula, here you have to put the value AE, as we know, AE put here, this comes out, AE is, that comes out cancelled, AE is there. Now you can take common from these two terms, A is cancelled and here it is 2 is cancelled and A is taking common, so AB into E into 1 root 1 minus E square plus sine inverse E. This will be the example number 5. Now this is a way to solve the questions of exercise 8.1. Now try to do the exercise 8.1 and do these examples in your notebook. Thank you. Have a nice day.